Hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. So today is day 7 of our 20 days of the statistics course. Let's start without any delay, right? So let's first discuss about the random variables, like what random variables are basically. So a random variable is essentially a bridge between the randomness and the mathematics, okay? It lets us assign numbers to certain outcomes so we can analyze them systematically. So there are now two types of random variables, okay? So let me just list that out for you. So random variables are basically of two types. So the first one is the discrete random variable, and the second one is the continuous random variable. Okay, talking about the discrete random variable first. So a discrete random variable, think of them as a countable outcomes. Okay, countable outcomes. For example, tossing three coins. Possible values for the random variable x is equals to number of heads, which are like 0, 1, 2, 3. So each has a probability. Okay. Talking about the continuous random variable. So these describe the measurements that can take infinitely many values within a range. Okay. These describe measurements. Okay. Describe measurements. For example, x is the height of the student, okay? So you don't just get 160 centimeter or 170 centimeter, right? But any value like 163.2 centimeter or 168.7 centimeter, etc. Okay? So probabilities are expressed over intervals. For example, the probability height lies between the 160 centimeter to 170 centimeter. Okay, let me give you another example of a discrete random variable. Okay, so another example of a discrete random variable is the number of emails received in an hour. Let me write that for you also. For example, number of emails received in an hour. And another example of the discrete random variable is the number of defective products in a batch. Number of defective products in a batch. Okay, and each value has a specific probability in this. Okay, talking about the continuous random variable, let me give you an example for this also. The first example was the height of the student, which I just gave you right now. Okay, height of students. And the second example can be the temperature during the day. For example, you cannot tell the exact temperature, it changes, so you range between them. So if someone asks you what's the temperature today, you would not be saying like exactly 33, because it's not 33 degrees celsius all throughout the day. You will instead say like 30 to 35 degrees celsius. So this is about the continuous random variable. Okay, so instead of probability at a single value, we give the ranges in that. Now another topic which we're going to study today is around the expectations. Okay, which we also known as the expected value. Okay, now let's talk about this. So the expected value represents the long-term average outcome if an experiment is repeated many times. It answers on average what value should we expect. Okay, so what does it answer? It answers on an average what value should we expect. What value should we expect? Okay, so expected value for the discrete random variable is, so let me write this formula here only for you. Okay, so the formula says like expectation of x is equals to summation of x multiplied by the probability of the x. And the formula for the continuous random variable of the expected value is expectation of x is equals to integration of x f function x, okay, where this fx is the probability density function. Okay, let me highlight this for you. Okay, this fx is nothing but the probability density function. Okay, let me write this here for you. Expected value is represented at ax. Okay, for example, let me give you example of this. If waiting time is uniformly distributed between 0 and 10 minutes, so the expected waiting time is 5 minutes. So let's further study about like the intuition of all this what we have studied. How is it important for the data science? So expected value now is widely used. So where it is used? So expected value is widely used first in the model evaluation. Okay. And for like calculating the average loss. Also, the expected value is used in the risk estimation. It is also used in business forecasting. Also, it is used in decision making under uncertainty. Okay, for example, if a marketing campaign gives like 100 rupees profit with probability of 0.6 and 50 rupees loss with the probability of 0.4, let me write that for you. Okay, for example, the marketing campaign for example gives 100 rupees profit, okay, with probability of, let me write P only for the probability of 0.6, and it gives rupees 50 rupees loss with probability of 0.4. So your expected profit will be 100 0.6 minus 50 0.4, which is equals to 40. So on average the campaign earns rupees 40 per ton. So this was all for today. So if you like the content, just like this video, subscribe my channel, and do not forget to hype my video. Meet you in the next day after 20 days of statistics. Till then, bye bye.